So far we have only looked at data types that can store only one value. So for example, foo is equals 10, and so foo just stores the value 10 and nothing else. Now we will look at a few data types that can store multiple values. So if you know other programming language, this will be arrays and things like that, which can where you can store a sequence of different things. Note that yeah, so as I was saying that just had an idea for a moment, but anyway, so let's look at that. And so the first thing that we will look at is known as a list. So list is Python's version of an array, and this is so an array or a list is just a collection of items. You know, it's just your shopping list, for example. It's just a list of things. So this foo is equal to 10 is one thing. So you can have a bunch of things and then put them in a collection, and that's what a list is. So let's see how to make that. So we'll have our foo again, and then let's not have foo. Let's have my list. And the way you define a list is within square brackets. So you give square brackets, and then you put different items that you need to go in there. So let's say 10 4 2.5 and Python. So few things to notice here. So I can do the type query again, and that will tell us that indeed this is known as a list inside Python. Notice that all the different things inside the list belongs to different classes themselves. So inside the shopping list, you can have different things, right? You can have let's say you can have a shirt, you can have milk, you can have fruit, and all of these things you can buy from different places. It doesn't really matter. It's just a collection of items, and the items what the items are doesn't really matter, you know. So you can put any kind of so you can make a collection of any kind of different things. In Python this is allowed. In C, for example, this is not allowed by like this is not allowed out of the box. You have to make a custom data structure for this, but in Python you can just do this out of the box, which is very handy. So now we have made a list, we have made a collection. How do we now get individual items off of that list? The way we do that is by is something known as indexing the array. So we type the name of the list. So notice that right now if I just do this, then we will get the entire list back. That is how any object in Python works. So for example, if I just say foo, notice that foo is defined as 10, so I'll just get 10 back. So if I just do my list, I get the entire list back. But in rather than getting the entire list back, what I can also do is get an individual item of the list back. The way we do that is we type the name of the list, and then we do this. We have a set of curly brackets, square brackets, and then we specify an index. An index is the position of the item in an array, in a list. So if we want to say get at 2.5, we'll have to count at what position this is. So this is 1 2 3, but if we say my list 3, you will see we will get Python back, because all lists and usually any kind of these collection type data structures in many or majority of the programming languages starts from 0. So this is index 0, this is index 1, sorry, this is index 1, this is index 2, and this is index 3. So that is why when we did mylist3 we get Python back. This is very important. This sounds or feels a bit counterintuitive in the beginning, but as you start coding and as you slowly start learning this will make a lot of sense. The reason this is done is that this makes counting easier. This makes counting from a computer perspective easier. So this makes it implementing different things, different higher level functions, or this makes working with these arrays much easier. That's why it is done that way. Just remember that arrays starts at 0. So if you want to have the first item in an array, you will have to say my array or my list. I should really say list. I'm just saying arrays, but so if you want to have the first item in a list, you just say my list and then you put a 0. This will in fact give you the first item, which is 10 in our case. If you want the second item, you have to say it with me, 1. There you go. So that is array, sorry, that is list. I have array stuck in my head. So that is list. There is also a related data structure to list in Python, which is known as tuple. So tuple is basically the little brother of list. The difference between a tuple and a list is that tuples cannot be modified where arrays can. So if I want to add an element to this array, I can do that. So all I have to do is say my list dot append, and then I have to give it some value, so new value for example. And now if I print my list again, you will see that the new value has been appended, so has been added to the array. So it's basically, it's just appending, so it just adds to the last position. What I can also do is so I can modify this array any way I like. Instead of retrieving a value, what I can do is I can say my 0 is equals to, so it's no longer 10, it's 23. And now if I say my list, you will see that indeed the first value is no longer 10, the first value is 23 now. So this my list is mutable. It is possible to change this. So this is known as a mutable object or a mutable data structure. This is the major difference between a list and a tuple. So let's create a tuple and then we will see what happens. So let's say my tuple, of course. I am choosing these variable names because there is no context here. So of course, as I said, that you should choose these variable names as appropriate in the context. Find the best variable name you can. So my tuple, and tuples are defined using parentheses. So you can do the same thing. So we will actually basically copy and paste this, or this, not this, but our first thing. And you can see that now this is a tuple. So this is a sequence. We can do the same thing as we were doing with so we can do my tuple and again square bracket 0, and we can do those things. We can retrieve a value. we can read from it. Let's say my tuple -1. So this is a cool trick. -1 represents the last value of any kind of list or collection. So if you want the last value, just say -1. That's just a small trick. So we can read values from a tuple. What we cannot do, however, is write to it. So we cannot change or modify anything inside this tuple. So if I in fact try to do that, let's see what happens. So my tuple, say 0 is equal to 23. You will see that I get an error. The tuple object does not support item assignment, which means that modifying this is not possible. So a tuple therefore is an immutable collection. So you can think of a tuple as an immutable list. So you may ask that why bother with tuple at all, because I might need to change things later on. I mean, I don't really know. The reason we use tuple is tuples are much more memory efficient because there is no overhead. Once you define this tuple, the computer knows that this is fixed, this is set in stone, this cannot be changed. So it can allocate the memory exactly and very efficiently. So therefore tuples are much more memory efficient. Whereas in list, when you created this list, the computer knows that you can change it later on. So what it does is it actually leaves a little bit of extra memory as an overhead, so that when you do these changes, it doesn't overflow and there are other concerns. So so tuples are much more memory efficient. But that being said, in simple programs, in day-to-day program writing, or when you are a beginner, you do not have to worry about this. Usually in modern day computers have lots of memory, so this doesn't really show itself when you are dealing with thousands of items. If you are dealing with millions of items or even billions of items, then these things will become a concern. But for thousands of items, doesn't really matter. Anyway, so that is list and tuple. There is one last collection object that I would want to talk about, and that is dictionary. So let's create a variable called myDict, and dictionaries are defined with curly brackets. That's the only bracket remaining, as you can see. Dictionaries are a very, very important data structures. In fact, when I write programs, I use this all the time. So list and dictionaries are used all the time. These are very, very useful. Dictionaries are key value pair structure. So what that means is, how do I explain this? Let me think of a nice analogy. It is like a phone book directory, so you have a name and you have a number, you have a name and you have a number. So if you have some data that has that kind of a structure, for example, if you want to store some data about some people, for example, or if you want to store some people's phone number, then this is very useful. For example, if you want to store your for example, there is a maths test and you want to store which student got what mark, then this is very useful. How? So here what happens is, so this is the structure. So you say key and then value, then comma, and then the next one. So key and value. So the key is the name, so let's say Sushant or someone, and then the value, for example, is, let's say 95. and then let's say another student is I'm just coming up with names here, it's fine, whatever you put. Let's say 87. Then let's say there is another one called Pooja, and maybe she got 100. Okay, enough. I'm tired of hanging out things. So now this is, of course, well, as you can tell, this is a dictionary, but what this structure allows you to do is ask for a particular value of one person. So what you can, for example, if I now ask you how much did Pooja get, with any other data structure you would not be able to do this immediately, because you have to first find out which location Pooja is at, and then you can ask the list, for example. But with the dictionary you can do it using the key. So we can do like this, and you can see that the number comes back. This might not seem very elegant or very important, or how would you even encode all this data if there are 500 students? Would you write all of these numbers by hand? Well, like, of course not. I mean, of course there are ways, there are methods, there are functions, there are libraries even for doing these things very, very efficiently. But at the base level they are working with a structure like this, and you will use a syntax like that to get someone's mark in exam, for example. So that is why we study these things, and then so that when the time comes we can use the knowledge that we gained here. So what did we discuss? So we discussed, I'll go to Visual Studio Code for a moment, and then I'll just write out here, and this gives me a nice opportunity to discuss another feature which is known as multi-line comments. I have forgotten the syntax, it seems. Let me look it up. So if you forget, or if you're not sure how anything in Python works, you just Google it, Python multi-line comment, right there, and you can look at Stack Overflow. There are other websites, of course. So there it is. Okay, no, yeah, okay, I was half right. So basically, okay, so in Python, as I was saying, that this is a single line comment, and in multi-line comment is just this. So this is a multi-line comment in Python. Comment, this will be ignored. So what did we learn today? We learned about numeric data types, which are float and int. I should really do it like this. We learned about character data type, which are string, and we learnt about booleans, not booleans, booleans, and then we learnt about collection data types, which are list, tuple, and dictionary. So these are the foundational elements of any programming language, including Python. Once you have learned this, we will learn how to use these data structure to write a program. So next up, we will write a program to add two numbers. So we will ask the user for two numbers, and then we will add them, and then we will print it out. So you can imagine that you can do anything with those two numbers. You can, you can find the LCM, GCM of them. Sorry, it's not GCM. You can find the LCM. You can you can find what happens if you raise one number to the power of another number, what have you. You can do anything with those two numbers. But we will start small. We will start with just adding those two numbers.